In this video I'm going to go through 2010 question 6 that appeared on the Junior Cert. So it's a sailboat. We have a parabola here. The curve AB is a parabola. So the first thing you do is look at the question and you kind of make sense of what they're trying to ask you. So in this case they're asking us to draw a parabola. We're told vertex at A, so I know then I've just put in a light construction line that these points are going to have to go to A here, right? So we'll probably go for 6 gaps like we would do normally. Then we have a curve CDG, which is that, with focal points F1 and F2. Now you'll notice that I have a dimension from here to here for C, which is 75, which G will also be 75 across here. So that's my major axis, and I'm not given a location of the focal point, so I need to know how to find the focal points. I know point E is down 24 and when it crosses the ellipse, I suppose I get my focal point. So there's just a little bit of thinking to do with that there. The line EH is a tangent, that's okay. Similar to that there, we're going to have to join it to the focal points, bisect it, get the normal. And then the curve LM is an identical portion of the curve CDEG or CDG. So that's basically copy that, paste it there, and that's the kind of fin that goes into the water. Okay, so to start this question, it's going to be, for this point here, it's down 140 and in 70. I'm going to draw a light line. Now I have it kind of partially started here, and I'm just going to zoom out here, a small touch. Right, I have a partially started, and I have C here, light line. I've measured up 110 and across. That distance there is 75. B is up 5. Right, so, and I have C there. Now G is also going to be 75, so that point there is G. I can throw that in, and I've just put in a small bit of this in heavy at the moment. I don't really know what's going on. Well, there's another 15 mil added on there as well. But we'll suppose I could just put this in temporarily. Well, just put it in. It just gives me kind of a bit of a structure on what the makings of the question and what I'm asked to do. I suppose this allows me then, when I have G, I can draw a straight line up. I have that point there. It'll allow me to draw on the sail here as well, which is kind of pretty straightforward. It's kind of taking shape there anyways for me. Okay, the parabola. Trick with the parabola, you want to go for 6 divisions. So I'm going to go off here at B, draw a line off at any angle. Just do this. Now this is all light lines. I might have done a little bit heavier so you can see it. So I'll go for 6. 1, 2, 3, 4, 5, 6. Right, 6 here. 6 will join back to here. Now these are going to be parallel, right? Handiest things here is you can do your sliding set squares, or adjustable set square would work out on the day of your exam. The best option for accuracy. Tighten that there. That's fine. Okay, I'm going to divide the base there into 6 gaps. Now just as it happens, I see 75 there. 6 into 75 is 15. Now so you could be tempted just to measure 6 gaps of 15, and that's what I'm going to do in this case. So 15, 30, 45, 60. 1, 2, 3, 4, 5. No, actually that's not good for me. I need to go for 6 gaps. So I will draw a line off at any angle as normal. Now for presentation and neatness, I'm going to come up here at the top and do it just so it's just out of the way and it's not going to infringe on my drawing later on. So I'm going to go for 6 gaps. 1, same idea again, 3, 4, 5, 6. Write down 6 there. Might just zoom in here a little bit on it so you can see it a bit better. Right, 6 will go to A. and all these will go back parallel So A is the vertex. So that means that these points here on the left will go to A, or joint A. Now all presentation very important. Accuracy, neatness. And there's my parabola done for the sale of the question. Right. Next step is the ellipse, right? So you see the focal points there. So they're part of the question is challenging the student to see does the student know how to get the focal points. So to get the focal points, you get half the major axis, like so. You go to, I suppose, are we right in saying that? Okay, no, we'll have to look at the question again. So if I look at the question, I see F2 is 67 mil away. So that's fine. So 67, 65, 67. So that is F1, right? And I'm going to mirror across this distance because it's going to be equal distance on either side. So that's F1, 67, and I'll just mirror across here. That's F2. So drawing an ellipse, I always draw classic ellipse. I draw two circles. Now there's no need to go the whole way around for this, for the ellipse. So that is my major axis there, right? Always a good idea to come out to the side of the sheet, just as a kind of like give yourself a bit of a chance to, especially on the day familiarity. If you have a big A2 sheet, go out to the side of the sheet, draw two circles like this, right? So I have my major axis and I have my minor axis, and then obviously to get a point on the curve, just do this in a different color. You know, we break up our ellipse. Now I'm just going to do this just so it kind of brings back technique and all that, gets you familiar with it. So just a small bit of notes there. So that's how we generally get our points on our curve and all that sort of stuff. With that we can divide it up. Just throw in another one there. Let's just make you kind of familiar with the technique. And then we judge in we draw in our curve as accurately as we can there. Okay, so a couple of bits of revision, and this is nearly for every ellipse question, is the focal points. To get the focal points, half the major, top of the minor, and swing an arc. F1, F2, right? So if I draw a line from here to here, that distance there is half the major axis. So I'm going to use this theory here now to help me solve the minor axis. So what I'm going to do is I'm going to get half the major axis, right? And like looking at this, if I go to F1 now and swing the arc, where the arc crosses here, that will give me my minor axis. So I might just draw this in here lightly, just to show you that distance there is half the major axis. And then that gives me a point on my minor axis. So now I can go back to my question here and I can draw in my minor circle. Once I have that done, then there we go. I suppose what's up next? I need to draw in the ellipse. So divide it up with my 60, 30 degree set square. I might just zoom in a little bit on this here so you can see a bit better. So then in this case it's going to be up and across. Points on my ellipse here then. Now, it's possible to get an additional point on the ellipse if you wanted one. So look, draw a line off at any angle, up and across. And you could do that an extra few times if you wanted to. May just help your accuracy. On your ellipse. Now I'm going to call this point here D. Very important to label all the points. Now I'm just going to dot this in here temporarily. And we're heading for G there. I'm going to keep my eye on G as I dot the. I want the most accurate curve I can get. Now it's advisable to maybe stand up, move around, to allow yourself to draw in the best possible just see there, best possible curve there for yourself. Okay, so I'm not going to draw in too much here now. I'm going to draw a light construction line down here for now. So that's my ellipse put in temporarily. I see point E there on the question is down 24, so I'm going to measure down 24 here, which is that. I'm going to draw a light construction line across here, and where that crosses here, I'm going to put this in blue here now, that is point E. Now I'm going to do this bit in blue so you can clearly see it. So if I read the question, the line EH is a tangent to the semi-ellipse at E. So to get a tangent, we have a tangent on a point on the curve. Step 1 is get the focal points. With that done, then step 2 is join the point E to the focal points. Okay, my next step then is to bisect this angle here. So start off, draw a small circle, extend on the compass there a little bit, back from there to there. Now what you write here then on it as well is you can write the word normal. Shows the examiner that you know what you're talking about. Now the tangent is always at 90 degrees to normal, so then again once you have your adjustable set square, it's very handy. Line it up like that. Let's just zoom out here a little touch. And then when I flip the set square, I'm going to draw a line here at 90 degrees. So just double check the angle there again, just before you do that. So you line it up like this. And I'm going to flip the adjustable set square, and I'm left with this here. So this angle here is that there. And I can just check it there with my set square there in the corner. So that gives me point H. I'm going to write H there. Gives me point H, right? Okay, now I have a line going from here. So look, I'm going to take this, my adjustable set square, and I'm going to flip it this way, and then that will generate a line here from F2 to this way here. That's a light construction line. Or that doesn't look right. It's fine. Just rub that out for 1 second. So this line here is at 90. Okay, so it's straightforward enough. I'm just going to get my set square. Suppose it should look something like this. Slide it on like that there. And we're going to come out from D here anyway, so I'll draw a construction line out from here. want to check that there. That should be down 24. Yeah, maybe just a little accuracy, might be a slight bit off mine there, but anyways, we'll keep going. There is that, and that means that that angle there is at 90 degrees. So I'm just going to put that in there, and that gives me the bottom part here of the sail. So I'm in a position now where I'm going to just heavy in this bottom ellipse here then. So that is that. The very last part then is the curve LM. So I measure down 30 here. Suppose I might just do a light construction line here across, and I measure out 15 here. That point there is L. So to get the curve, so it's very simple. I'm going to come up here now. I'm going to do this in red, so it's clear how to do this. So you come up here and you measure a series of tens: 10, 20, 30, 40, 50, 60. That might be even fine. I'm going to write here 0, 1, 2, 3, 4, 5. Okay, and then I'm going to go up here, and from 1 red line down, 2 red line, 3. This is all light lines, so I'm just doing this here though for just to show you there on that. Okay, your next step then, you go down here, and I'm going to measure tens here. You can see there you might even need all that, so that's fine. 0, 1, 2, 3, 4, 5 if I need it, but unlikely. So this is the way it works. I'm going to draw a light construction line here at 1, 2 and 3 for now. Okay, so we're copying and pasting the curve here. So this is what I do. I point my compass here and I put it there. So that's the distance there. I then go down to 1 here and I swing an arc. I transfer that distance, right? That's so I'm copying in stages. Then I go here to 2. Then I go here to 2. I go to 3 then here. And then there's 3. And I'll go to 4 here as well. So I'll just draw in an extra construction line. I'll do this in pencil. As you saw, this is done in pencil here. So there's 4. There's that. 4 goes there. Now, if you want a bit more accuracy there, like, you know, there's a big jump between that there, you could measure 5 mil here. Light construction line down, come up here 5 mil, construction line going across this way. Right, measure this distance here. You can just see it there in the camera there now. That, go down here, mark that off. So that concludes this question there. Very doable question. There is a parabola in it. Draw an ellipse with given the focal points and the major axis. right? There's then a tangent with a point on the curve, and then we have copying a portion of a curve there as well. 20 minutes to do that there, so it's very possible to do that in 35 minutes is what you'd have on the day of the junior cert, so time shouldn't be an issue with this question at all, so provided you know what you're doing. Okay, thank you, bye bye.